All right, composition of functions. So let's start with two functions. F of x equals 2x minus 3. G of x equals negative x squared plus 7. Very little new concept today. We're doing new stuff, but using stuff you already know. So there's not like, we need to talk through a page length of notes on new stuff. It's not like that. The only new stuff is maybe the notation that we'll use. So let's just use these functions, and let's back up and do some easy stuff first here. Let's find f of 3 and g of negative 2. In fact, I think you can do that, so I'm going to press pause and give you a couple minutes to do that. Square the negative 2, you get positive 4, then stick the negative on there. Negative 4 plus 7 is 3. Okay, that's pretty easy stuff. What we're going to do today is something that you might not have seen before. Fog of x. It's not times. Be careful. I should have been a little more careful with that circle. That is not a dot. That is an open circle. It's an open circle. And what it means, people will say it fog, pronounce it fog. Yeah, you've not done this. But when I write it like this, you might be okay. What that means is f of g of x. Thank you. F of g of x. Okay, so this definitely looks new by your reaction. That's okay.
I hate double parentheses.
So, well, be careful. We're not multiplying, but it's whatever's on the inside is the input to the f function, right? So f of 3 meant plug in 3.
In this case, we're just going to plug in 3.
F of g of x means plug in g of x.
Which is 3. So it's literally just g.
Wait. Back up here. G of negative 2 is 3, but g of x
is negative x
is negative x squared plus 7. G of x is negative x squared plus 7. So now we're going to take our f function, and instead of plugging in 3, we're going to plug in negative x squared plus 7. So let's look back at our f function. The f function is 2 times the input minus 3. 2 times the input minus 3. That's what the f function tells us to do. So our input, the first problem we just plugged in 3, no big deal. This time we're going to plug in negative x squared plus 7. And I mean, it's easy from here, distribute, combine like terms, whatever. But f of g of x means g of x is now the input to f. So let's see here. So that would be negative 2x squared plus 14 minus 3. Negative 2x squared plus 11 is f of g of x. And you can write fog if you like writing or saying fog. Yes. Okay, so it's very much related to what you've done before. You've definitely done f of 3. That's easy. It's the same process, the same procedure, except instead of a 3, you have to put all of g of x in there. All right, Goff of x. Well, follow the same patterns here. That would mean g of f of x. Again, I'm trying to slow it way down here. So I'm looking at the g function. My input to the g function is now the f function, which is 2x minus 3. The g function is negative square the input plus 7. Right? That's what the g function is. Looking all the way back at the top. Negative input squared plus 7. But now instead of an x there, we're going to put 2x minus 3 there. because that's f of x. This one's a little bit uglier because I've got to square 2x minus 3 and then put the minus on after that. So it shouldn't be terrible, maybe it's just annoying, right? I got to FOIL that out and be careful with the minus sign. I'm going to FOIL it all out first, get it cleaned up, and then put the negative on everybody. Well, on everybody in not 7. Let's see, 2x times 2x is 4x squared. The O and the I of the FOIL are the same. They're both negative 6x. So negative 12x. Right, I'm just trying to save a little space here. Plus 9. And then plus 7. And then I need to take that negative sign and put it on everybody. Everybody in the parentheses anyway. So negative 4x squared plus 12x minus 9 plus 7. So negative 4x squared plus 12x minus 2 is g of f of x, or if you'd rather just say gof of x. Yes, no?
Yes.
A few yeses. Okay. Let's try, so that was 1 and 2. Let's do a couple more. That was f of g of x and g of f of x. With the same f and the same g, let's try f of g of negative 1. F of g of negative 1. So as always with parentheses, start on the inside. Okay, negative 1, can't really do much with that. G of negative 1, I can do that. So that's, the g function is negative input squared plus 7. So what did you say that was?
That's 6.
That's 6. So g of negative 1 is 6. So back here on this main screen here, g of negative 1 is 6. So now we'll input the 6 into the f equation. Input the 6 into the f equation. Input the 6 into the f equation. So yeah, 12 minus 3 is 9. F of g of negative 1. Once we get started on these, you kind of realize there's two different types of problems. There's the ones that have an X in them, and then the ones that have a number in them. And most students, for whatever reason, prefer one or the other, and don't like the other one. I mean, that's basically it. I want to do a couple more examples, but that's just about it. How about g of 0? G of 0. Start on the inside. Okay, start to 0. Can't really do much there. But you can find g of 0, and then that becomes the input to g again. So you try that one. G of 0. So g of 0 is 7. But I'm only like halfway done with the problem. That's the inside stuff. G of 0 is 7. Now I need to use the g function again and put 7 in. Negative 7 squared plus 47, that's negative 49 plus 7 is negative 42. So you've kind of done all this before, you're just doing it multiple steps at a time. So just be careful. And I guess the new stuff is this writing it like fog of x and gof of x. That's the new stuff. Let's do one more. I'm going to rewrite f of x because I lost it when I turned the page here. So depending on where you are, you may not need to write f of x again. Let's try f of a plus 2. I think that's about as hard as I can make it. F of a plus 2. So grab the f function. This is sort of related to the bonus on the test. Grab the f function, and instead of plugging in 2 or 0 or negative 5, we're going to plug in a plus 2, which means we're probably not going to get a number answer. We're going to get an answer with a's in it. So that would be 2a plus 1. But that's only like the first half of the answer.
Yeah, that's the hardest you can do.
Is that a challenge?
That's what he said.
No, I mean, that's about as hard as they get. I guess I should phrase it that way.
Okay.
F of 2a plus 1. So, again, I'm going to grab the f function. But instead of an x, my input is now 2a plus 1.
2 minus 3.
So that would be 4a plus 2 minus 3. 4a minus 1. Yeah, that's about it. I want to work one together with you. So the next page in your notes is this kind of extended word problem here. Let's work through this together. So find that. It's the next page of the notes. Composition of functions. Real world example. I don't know what this quadrant business is, but we'll just walk through it. A new car dealer is discounting all new cars by 12%. At the same time, the manufacturer is offering a $1,500 rebate on all new cars. Mr. Navarro is buying a car that is priced at $24,500. Will the final price be lower if the discount is applied before the rebate, or if the rebate is applied before the discount? Well, which one do you say it is?
It's before, which is 12. It'd be 12% of a bigger number.
I think you're right. Let's walk through this and put some math onto Jack's thought process. Goodness, some of this is easy. What is the decimal for 12%? 0.12. Great job. How do we calculate 12% off?
Multiply by 0.12 and then subtract it.
Multiply by 0.12 and then subtract it. So, there's a different way.
You could multiply it by like
Uh-huh.
0.88.
Yes, that's right. The other way would be multiply the original by 0.88.
That's it.
I mean, with the calculator, it wouldn't matter which way you go. So you don't have calculators. You would have a calculator on one like this, but so right now, just trust my calculator. So 21,560. We could verify that 0.88 trick would work, and it does. So how do we calculate? I don't guess it asks us to calculate, but I don't know how else to answer that question. What is a function p of x to determine the cost after 12% off? So how do you, what's the price after you take 12% off? If x is the original cost, what do you do to get 12% off? Yeah, one way would be to just say x times 0.88. That would be the easiest way to do it.
So it's going to be p is x times 0.88.
No, p of x is x times 0.88 because p calculates the new cost after 12% off. So p tells you the new cost after you've taken 12% off. Maybe it's easier once we do r as well. R tells you the new cost after the rebate.
So we've defined the percent.
Is that from the original price?
From the original price.
12%.
But the rebates, remember the rebate was $1,500.
So we have to find out what percent 1,500 is of that.
No, because the rebate is not a percent thing. The rebate is just straight $1,500 off the
Just
cost.
subtract 1,500 from X.
Subtract $1,500 from what?
X.
From X.
That's price.
So X minus 1,500 would be the sort of the rebate function.
I don't like that.
Okay, so now we get into this. What does P of R of X represent? Basically, which one comes first in P of R of X?
The rebate.
The rebate comes first because that's the one on the inside. So be careful, you're not like reading left to right, like, oh, P comes first. Like, no. Math-wise, parentheses, the R comes first. So what does that represent? It represents rebate, then, what we won't call that other one? Rebate, then percent, I guess. Rebate, then percent off. As opposed to R of P of X, that represents percent, then rebate.
Thanks for that question.
Why is it?
Jack already has a guess that he thinks we think we should do the percent off first, and I like your reasoning. Let's find it. So if we take the rebate off $2,450, that would be $2,300. 23,000, yes. Let's see. So rebate off of 24,500 is 23,000, and then the percent off of 23,000. That's the 0.88 thing times 23,000. 20,240. So rebate then percent, we'd be paying 20,240. But Jack's contention is we should take the percent first because we're taking the percent of a bigger number. So let's see, percent of 24,500. So 88% of 24,500. Again, just trust my calculator here. Is 21,560. That's the percent function. But then the rebate function of 21,560 means subtract 1,500. $20,060. So percent then rebate, not a good new car, no, but certainly a decent used car for that.
But manufacturer
Okay.
would be offering a deal on.
So Jack was right. By, what is that, $180. Better off to take the percent off first and then get the dollar off. The main point of this problem is, does the order of composition matter? Yes. F of g of x does not necessarily equal g of f of x.
So R of P of X is
Which is a better buy. Let's see. R of P of X percent first is what we want to do. I'm not sure what it wants you to put for Y. You could go the simple route and say Y because it's cheaper. I don't know that that's what they're looking for. The better Y would be what Jack said earlier. You're taking the percent of a bigger number, so you end up with a bigger discount. The flat $1,500 off, that didn't matter as much. Right, that R discount was always going to be $1,500. That's a good way to say it. The P discount depends on how much the car costs, and the more it costs, the more you save. And that's a dangerous way to go shopping, right? Hey, the more I spend, the more I save. Well, yes, but you're still spending more. Okay, today's assignment is this worksheet 6-1. No packet, or I mean, it's in the packet. I do want to flip to the back and do a couple of these together because the picture isn't defined real well and also isn't really labeled very good. This first one is f of x. The second one is g of x. And the grid size is 1, so if you can't read the numbers, the grid size is 1. So let's do a few of these together. F of 0. So do you know how to evaluate a function using a picture?
Yeah, 2 and 4.
F of 0. So when x is 0,
8.
f is 8. So f of 0 equals 8. So those are super easy questions once you know what you're looking at or looking for. Let's jump down to number 17, f of g of 2. So job 1 would be g of 2. I'll start picking on people here. Yes, g of 2 is 0 because I go look at my, make sure you look at the correct graph.
So it's just f of 0 again.
And yes, that is f of 0, which we already found to be 8. And then number 20, Goff of 3. I don't like it when it looks like this because it's tempting to do the G first, but you don't have to rewrite it. I will frequently rewrite it because when it's in parentheses, it's more clear that you want to do f of 3 first. So f of 3, Aaliyah, can you tell me what f of 3 is? Good. I think you're right. -1. It's kind of hard to read, but look at the graph of f. When x is 3, y is -1. So there's 3, 1. So f of 3 is, or 3 -1 is -1. And then g of -1. Don't call it out loud because I want Liam to tell us this one. So g of -1, go to the graph of g. Find x is -1, Liam, and then the y value is 1. So the picture problems are easy as long as you're careful to look at the correct graph at the right spot. The mistakes people make are they look at the graph of f when they're supposed to be looking at the graph of g. Like it's just a dumb mistake. So be careful. Jack?
Number 19,
Uh-huh.
after you do the g, -2, you get -2,
Right?
but there's no -2 on the graph.
Oh, good question. Okay, 19. G of -2 is -2. Yes. F of -2. Well, can you think of a mathy word for what you said?
That's undefined.
I would say undefined. No solution would work too. Because f is not defined over at -2. There is no f of -2. Okay, for number 25, there needs to be more instructions there. It says find f of g and g of f, but there's nothing, there's a set of points, but it's not a good question. So let's find, no, we don't want to exit out. Let's find f of g of 3 and g of f of -4. Both of those will work. So now we're trying to evaluate functions not from an equation, not from a picture, but from a set of ordered pairs. So I'll do the first one with you. F of g of 3. Plus this will confirm if I wrote this problem right. So g of 3. Start on the inside. What's g of 3? 1. Because 3, 1 is a point on the graph.
Is that still using this graph up there?
So it's not using the graphs up there. That's a good question.
Oh, okay.
So put a break there. That's a good point. So g of 3 we said was 1. What about f of 1? -2, because now we're looking at that point to get -2. Again, super easy if you understand what you're looking for. Like no computation, no calculator. Just you understand X's and Y's, inputs and outputs, function notation. All right, so today's assignment is this worksheet. The first page of it maybe takes a little bit of time. Second page will go super quick because there's no calculations to do. And we can just mark out 26 altogether because I don't know what you're supposed to do with only 3 points given. So yeah, just mark out 26. I don't know what that was supposed to be. All right, so still almost 20 minutes left. Yep.